a vast international experiment designed to demonstrate that nuclear fusion can be a viable source of energy, is halfway toward completion, the organization behind the project said Wednesday. Construction of the International Thermonuclear Experimental Reactor, or ITER, in southern France, has been dogged by delays and a surge in costs to about €20 billion, $23.7 billion. ITER's Director General, Ronald Bigot, said the project is on track to begin superheating hydrogen atoms in 2025, a milestone known as first plasma. Fusion involves placing hydrogen atoms under high heat and pressure until they fuse into helium atoms. When deuterium and tritium nuclei, which can be found in hydrogen, fuse, they form a helium nucleus, a neutron, and a lot of energy. This is done by heating the fuel to temperatures in excess of 150 milillion degrees centigrade, forming a hot plasma. Strong magnetic fields are used to keep the plasma away from the walls so that it doesn't cool down and lose its energy potential. These are produced by superconducting coils surrounding the vessel and by an electrical current driven through the plasma. For energy production, plasma has to be confined for a sufficiently long period for fusion to occur. "We have no contingency plan," he told the Associated Press in a phone interview from Paris. ITER is the most complex science project in human history. The hydrogen plasma will be heated to 150 million degrees Celsius, 10 times hotter than the core of the Sun, to enable the fusion reaction. The process happens in a doughnut-shaped reactor, called a tokamak, one which is surrounded by giant magnets that confine and circulate the superheated ionized plasma away from the metal walls. The superconducting magnets must be cooled to -269 degrees centigrade, as cold as interstellar space. Scientists have long sought to mimic the process of nuclear fusion that occurs inside the Sun, arguing that it could provide an almost limitless source of cheap, safe, and clean electricity. Unlike in existing fission reactors, which split plutonium or uranium atoms, there's no risk of an uncontrolled chain reaction with fusion, and it doesn't produce long-lived radioactive waste. A joint project to explore the technology was first proposed at a summit between U. The project's members, China, the European Union, India, Japan, South Korea, Russia, and the United States, settled on a design that uses a doughnut-shaped device called a tokamak to trap hydrogen that's been heated to 150 million degrees Celsius, 270 million Fahrenheit, for long enough to allow atoms to fuse together. The process results in the release of large amounts of heat. While ITER won't generate electricity, scientists hope it will demonstrate that such a fusion reactor can produce more energy than it consumes. There are other fusion experiments, but ITER's design is widely considered the most advanced and practical. Scientists won't know until 2035, following a decade of testing and upgrades, whether the device actually works as intended. Still, fusion experts said Wednesday's milestone was noteworthy. The glass is half full, rather than half empty, said Tony Dunn of Eurofusion, a consortium of European research organizations and universities that provide scientific advice for ITER. Dunn said the appointment of Bigot had helped the project overcome what he called a very difficult period during which political considerations had hampered construction of what some consider the most complicated machine ever built. Cost remains an issue, though, and Bigot was visiting Washington on Wednesday to drum up support from the United States, which contributes about 9% of the budget. That includes General Atomics, which is building the central solenoid, an 18-meter, 59-foot electromagnet that's powerful enough to lift an aircraft carrier. Bigot said most other members, including the European Union, which pays 45% of the budget, had pledged their financial support for years to come, and he was hopeful the Trump administration would see the benefits of staying on board. Should Washington cut its funding, the project won't collapse, he said. It's too important for the other members. But there will be some delay. Gerald Neverdal, a professor of applied physics at Columbia University, said fusion could help solve the problem of how to reliably produce large amounts of electricity without emitting greenhouse gases, noting ITER's current cost is comparable to that of developing a large passenger aircraft. Energy is such an important part of our technological society that expenditure of $20 billion to develop a new energy source is really not out of line, he said.